Okay, question 14. We have parametric equations. So curve C has parametric equations. X is equal to 3 add 2 sine t, and y is equal to 4 add 2 cos of 2t, where t is between 0 and 2 pi. Part A wants us to show that all points on C satisfy y is equal to 6 minus x minus 3 whole squared. Now it's only 2 marks, that seems pretty stingy to me, but there we go. So, notice there's an x minus 3 squared. Now, over here, we got x is 3 add 2 sine t. Now, we could get then that if x is 3 add 2 sine t, then we can get x minus 3 is equal to 2 sine t. Now, if we also look at what's going on in y, we got 4 add 2 cos of 2t. Cos of 2t is cos squared minus sine squared. So we could write y as 4 add 2 lots cos squared t minus sine squared t. Now cos squared we can write as 1 minus sine squared. So we've got y is equal to 4 add 2 lots of 1 minus 2 sine squared of t. So we've got y is equal to 4 add 2 minus 4 sine squared of t. So y is equal to 6 minus 4 sine squared of t. Now up here we know that x minus 3 is 2 sine t. So 2 sine t is x minus 3. If we square both sides, we get 4 sine squared t is equal to x minus 3 squared. And therefore, y is equal to 6 minus x minus 3 all squared. Cool. And B part 1 wants us to sketch the curve C. So, it's quadratic. We can see the turning point is gonna be at positive 3, positive 6. So, we know that much. Now we also need to think about the range of values that x can take and y. So, because x is 3 add 2 sine t, the maximum value of sine t is 1. So x can be between, so when sine t is 1, x is 5, and the minimum value of sine t is minus 1. So when sine t is minus 1, x will be 1. So let's also do the same for y. So we know that y, cos of 2t has a maximum value of 6. Cos of 2t has a maximum value of 1. So y has a maximum value of 6, which we already know from the turning point, and cos has a minimum value of minus 1, so y has a minimum value of 4 minus 2, which is 2. So the graph is going to look something like this. So our turning point is at 3, 6. The coordinates of this point are going to be 1, 2, and the coordinates of this point are going to be 5, 2. So, I guess we should also put some axes in to show that we never hit. Cool. Okay, then B part 2, sort of already covered it. We want to explain briefly why C does not include all points of y equals 6 minus x minus 3 whole squared, where x is in the reals. So it's because, and you would want to say something along the lines of x and y are bounded by minimum and maximum values, as we've already shown up above. Okay, then for the final part, we are told the line with equation x and y equals k, it's the curve C at 2 distinct points. State the range of values of k, writing your answer in set notation. Okay, so what we're going to do is get an expression for either y or x in terms of the other one, substitute that into our equation for C, solve it, have a good time. Right, okay, so we know that y is equal to 6 minus x minus 3 all squared. We also know that x and y is equal to k, so given that y is all on its own in the top equation, let's get y on its own in this one. So we can get here that y is equal to k minus x. Now we're going to substitute that into this guy here. So we're going to get k minus x is equal to 6 minus x minus 3 squared. So this is going to expand and simplify into a quadratic. So we know that this to here has 2 distinct solutions. So, if we expand, we get k minus x is equal to 6 minus x squared minus 6x add 9. Now I'm going to add all of that bracket to the left, so we get x squared minus 6x, add 9, add k minus x. Now I'm also going to move this 6 over to the left, so minus 6 is equal to 0. Right, let's simplify that. So we got x squared, and we got minus 6x, minus another x, so that's minus 7x. Then we got add 9, add k, minus 6. So we get add 3, add k is equal to 0. Now, because there are two distinct solutions, we know the discriminant of this is greater than 0. So, for two solutions, b squared minus 4ac is greater than 0. So, a is 1, b is minus 7, and c is 3 add k. So, minus 7 squared is 49. So we get 49 minus 4 times 1 times 3 add k. So that's going to give us minus 12 minus 4k is greater than 0. So we get 37 minus 4k is greater than 0. 40. So 37 is greater than 4k, and then finally we can say that k is less than 37 over 4. Okay, so that is our upper bound for k. There is also going to be a lower bound for k. So, it's at this point I realise it would have been handy not to erase my graph, but never mind. So remember our graph looked something like this, where this point here was 1, 2, and this point over here was 5, 2. Now, x add y is equal to k is the same as y is equal to k minus x. So it's going to be a straight line with a negative gradient. So where is the lowest value that it can cross the curve C? Well, it's going to be here at point 5, 2. Anywhere else, and the value of k is going to be higher. So if we move up, k gets higher. If we move down, we don't have two solutions. So what we're going to do then is to find the value of k is substitute in x equals 5 and y equals 2. So when x is 5 and y is equal to 2, k is equal to 5 add 2, which is 7. So we now know then the range of k is such that k can be greater than or equal to 7, but less than 37 over 4. Apologies if you can hear the rain, it's Cornwall. So, finally, written in set notation, we would say the range of k is k such that 7 is less than or equal to k is less than 37 over 4. And that's it. Paper done. Okay guys, really hope you found this useful. I'll start work on paper 2, so hope to see you there. Good luck in your exams.